Hi YouTube, continuing question 6 for the FP2 2012. Sigma notation, partial fractions in A, the method of differences to prove the expression in B, and to show that 2nn plus 1 is the expression in C. So for partial fractions in A, considering the form A over R plus B over R plus 2, multiplying both sides by the lowest common denominator gives the identity here, and then trying R equals minus 2 and the constant gives values for A and B, and we can write down the form required. So for part B, using the result from A and expressing in sigma notation gives 1 over 2r minus 1 over 2r plus 2, and then considering the method of differences, using 5 terms and subtracting, we can see that 3/4 minus 1 over 2n plus 1 minus 1 over 2n plus 2, and simplifying this expression gives the proof required. So then for 2nn plus 1 for the expression, using our result from B and considering 2nn plus 1 is 2n minus n, substituting for 2n on the left hand side, using our result from B and simplifying gives the proof required. So the partial fractions, proof in B and the proof in C. Question 7, calculus substitution, to show that the substitution y equals vx transforms 1 into 2, and then by solving 2 find a general solution of 1 in the form y equals f of x, and then finding the value of dy dx at x equals 1 given y equals 2 at x equals 1. So for part A, given y equals vx, differentiating implicitly gives an expression for dy dx, and then substituting in equation 1 and simplifying simplifies to the proof, equation 2. So for a general solution of 2, from observation we see it's separable, so integrating both sides gives a general solution. So considering the form y equals f of x, simplifying further to here and using the laws of logs, where a equals e to the power 2c, considering that v is y over x, substituting for v and simplifying further to y cubed and to y equals the cube root of this expression. So for part C, given y equals 2 at x equals 1, substituting in equation 1 gives 12 dy dx equals 9 and dy dx equals 3/4. So question 8, a final question in this paper, complex transformation. The point P represents Z such that this expression is satisfied, and the point Q represents Z where arg Z minus 6 equals minus 3 pi over 4 is satisfied. To sketch the locus of P and the locus of Q as Z varies, and to find the complex number for which both expressions are satisfied. So for part A, applying first principles, evaluates to a circle, giving proof with center 4 minus 2 and radius root 20. So for the locus of Q, given arg Z minus 6 equals minus 3 pi over 4, from observation we see it's a half line starting at x equals 6 and inclined at pi over 4. So, and we'll have equation tan pi over 4x minus 6. And the sketch here shows the line, the half line and the circle. So for which both, the complex number for which both are satisfied, to satisfy both, considering they will intersect, then substituting x minus 6 into the circle, which gives a quadratic, and solving gives x as 4 plus or minus root 10. Considering the half line, then x will be 4 minus root 10. Substituting in the straight line equation gives y minus 10 minus root 10, so we can write down the complex number required. So first principles for the locus of P and the half line. Thank you for watching. I'll start further pure 3 in the next video.